How are you, my friends? This is review questions number 2 on vectors in 2 dimensions and systems of equations, linear and non-linear. Question number 1, solve the system by any method. This is a linear system, as you can see, but you have to rearrange it because we have so many fractions. Remember also here, we have x and y, there is y and x. Just be careful when you rearrange. So let's rearrange, multiply the first equation by the LCD. We have 2 and 3, so the LCD will be 6. And the second one, the LCD will be 10. I will show you the first one. So multiply by 6 here, 3 over 2, x minus 1. If you multiply by 6, 6 divided by 2, 3 times 3 is 9, x minus 1. 6 here times 2 over 3. So 6 over 3 is 2, and there is another 2, so minus 4, y plus 1, and on the other side we have here 60. Same thing for the other equation. But remember, in the second equation, you have 8y here. When you multiply 8y, you have to write it here, the second term, 5x, the first term, because we have to line up the x, line up the y. We have the constant on the other side. Let's call this equation 3, and this is equation 4. So equation 3, we can multiply by only 2. So we will get here minus 8y, and here we get 8y. Remember to multiply by 2 the whole equation 3. So 9 times 2 is 18x minus 4y is equal 146. Second equation, write it. When you add the equations, this is elimination method, you can eliminate the y. So on the next slide, you add, you get 23x is equal 146 minus 31, 115. Divide by 23, you get x equals 5. Now you can choose equation 3 or 4. Easy. The easy one, I can choose equation 4. Replace x by 5. So we put here 5 times 5 plus 8y is equal minus 31. Simplify, you get y equals minus 7. So the point of intersection or the solution will be 5 and minus 7. Question number 2, find the number of solutions of the nonlinear system x squared minus 3xy plus y squared is equal to 4, x squared minus 5xy plus 6y squared is equal to 0. Let's call the system here. The first one is equation 1 and the second is equation 2. We can notice here adding or subtracting the equations will not give any help. So instead, I can take equation 2 since I have a 0 here and factor it. So I will factor equation number 2, x minus 2y times x minus 3y is equal to 0. Then I can take this one, x is equal to 2y. This is equation A. X equals 3y. This is equation B. So I will take each equation separate. X is equal to y and replace it in equation 1. When I do that, I will get y squared is equal minus 4, which is rejected because that's a positive number and this is a negative number. Now I can take equation B, x is equal to 3y, and replace it in equation 1 also. I will get y squared is equal to 4. If you go by the calculation here, please, by checking, y squared is equal to 4, so y will be plus or minus 2. So I can find the x now. If I replace this in B, so y is equal to, I go to equation B, I get x is equal to 6. If I put y equals minus 2, I get x equals minus 6. Now the proposed solutions are 6 and 2. This is x and the y, minus 6 minus 2. So the number of solution is 2, but you have to check. Checking is shown in details on the next slide here. So you can check each proposed point in every equation. You can check it, and both points are acceptable. Given the vectors v, minus 6 square root of 3j minus 2i, and vector u has the magnitude 2 and direction angle 7 pi over 6. There are 3 parts here. Find the magnitude and direction angle of the vector minus square root of 3u plus v over 2. Find the dot product of the vectors u and v are the vectors u and v orthogonal? Explain your answer. Now for the solution of question number 3, first we need to find the components of the vector u. We use the formula u equals the magnitude of u cosine theta, comma, the magnitude of u sine theta. Just put the numbers there. So the vector u can be written as 2 cosine 7 pi over 6, 2 sine 7 pi over 6. 7 pi over 6 is an angle in quadrant 3. The cosine of that angle is minus square root of 3 over 2, and the sine of that angle is minus half. So put the numbers here. So u will be minus square root of 3 minus 1. Remember, this is u. V is given, but we have to rearrange it. Let's call capital M, the vector, minus square root of 3u plus v over 2. This is given here. You can see that in the question. See, minus square root of 3u plus v over 2. V over 2 means half times the vector v. Remember, v is minus 2 in the x component, minus 6 square root of 3. And here we multiply the u by minus square root of 3, and u itself is there. So multiply these numbers and then add. You will get 2 and then minus 2 square root of 3. Let's call this capital M as I mentioned. This is in quadrant 4 because x is positive and y is negative. Now the rest are easy. 3 parts. We have to find the magnitude of the vector M. The square root of a squared plus b squared. So this is 4. Remember, you square all this x, you square all this y. The square root of 16 is 4. To find the direction angle, find tan theta. Let's call this E and F. So tan theta will be minus 2 square root of 3 divided by 2, which will be minus square root of 3, and the reference angle is pi over 3. Since the vector M is in quadrant 4, so we can find the theta direction angle 2 pi minus pi over 3, which is 5 pi over 3. Now B part is easy. Find the dot product of the vectors u and v. The dot product is AC plus BD. This is A and B, this is u, and this is v. So find the dot product, u times A times the C, B times the D, it will be 8 square root of 3. The question in C part, the vectors u and v are orthogonal? No, they are not orthogonal, not perpendicular, because the dot product is not 0. It is a number here not equal to 0. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.